Hello students, welcome to this lecture on statistics. In this lecture, we will cover NCERT section 13.4.3 to 13.5.1 and example 8. This is disclaimer. We will start today's lecture by looking at the limitations of mean deviation. Then we will discuss variance and standard deviation. After that, we will focus on standard deviation. So standard deviation is defined as the square root of the variance. Then we will solve NCERT example 8. So students, make sure you are with notebooks and pens ready. So let's get started. Let's start by looking at some of drawbacks of using mean deviation in statistics. So mean deviation is a way to measure how spread out data values are, but it has some important limitations. So we will go through this step by step to understand why we might need a better measure in statistics. First, notice that when our data values are very spread out, the middle value, which is called the median, might not really show us the true center of the data. For example, if we have the numbers 2, 3, 4 and 100, the median is 3.5, but most of the data is far from that value. So the median can sometimes be misleading when the data is unevenly spread. So when the data values are very spread out, the middle value may not show the true center. Because of this, if we calculate the average amount of difference from the median, which is called mean deviation about the median, it might not give us a reliable picture of how spread out the data really is. Okay. Another point to notice is that the total difference from the average or mean is usually bigger than the total difference from the median. For example, if we have data values 1, 2, 3 and 10, the mean is 4 and the median is 2.5. So if we add up the absolute differences from each, the sum of from the mean is larger. So this shows us that the mean can be more affected by extreme values or outliers, because the total difference from the mean is often bigger. The average amount of difference from the mean, which we call the mean deviation about the mean, is not always accurate. Another drawback is that mean deviation only uses positive differences. That means it ignores whether the difference are above or below the center value. So for example, if we have values 2, 4, 6 and the mean is 4, the difference are -2, 0 and 2, but mean deviation just uses 2, 0 and 2. Because of this, we cannot do more advanced math with the mean deviation easily. So like we can with other measures. So because of all these problems, we need a better way to measure how spread out our data is. So we want a measure that takes into account both the size and direction of differences, and that works well even when the data is uneven or has outliers. So due to these limitations, another measure of dispersion is needed. So now we are looking for another measure of dispersion in statistics. All these drawbacks point to the need for a better measure of spread in data. So this is where standard deviation comes in. So standard deviation is a squared differences from the mean, which allows us to do more math and get a more accurate picture of how spread out the data is. So we will learn about standard deviation next. So let's start by thinking about why we need the concept of variance in statistics. So variance helps us measure how spread out the values in a data set are. So it's important because just knowing the average or mean doesn't tell us how much the values differ from each other. So today we will explore why variance is used and how it's calculated. So first, let's recall what happens when we try to measure how far values are from the mean or median. So if we just add up the differences, the positive and negative values can cancel each other out. That's why when finding the mean deviation, we take the absolute value of each difference. This way, all the differences are counted as positive, so we get a true sense of the spread. Another way to avoid this problem is to square all the differences. Squaring makes all values positive or 0. Now, let's define our observations. Suppose we have n observations, x1, x2, and xn. The mean of these observations is written by x bar, which is the sum of all the x values divided by n. So x bar is basically equal to x1 plus x2 plus plus xn divided by n. So we will use these symbols as we build the formula for variance. The next step is to look at the sum of the squared deviations from the mean. So this is written as sum x summation xi minus x bar xi minus x whole square, where we subtract the mean from each observation and square the result, and then add them all up, and this sum tells us how much the values deviate from the mean overall. Remember, squaring makes all the differences positive. If this sum is 0, it means all observations are equal to the mean and there is no spread. If the sum is small, the values are close to the mean and less spread. If it is a large value, then the values are more spread out to each other. So let's make this idea clear with a complete example. Okay, so we will work through a set of numbers step by step to see how variance is calculated and why it is useful. So pay attention to each stage, and as each step builds on the previous one. So here is our example data set, which we will call set A. The observations are 5, 15, 25, 35, 45, 55. These are the actual values we will use to calculate the variance. So notice how the numbers are evenly spaced, which we will make our calculations straightforward. So first, let's calculate the mean or average of set A. So we add up all the numbers. So 5 plus 15 plus 25 plus 35 plus 45 plus 55, which equals 180. Then we divide by the number of observations, which is 6. So mean equal to 180 divided by 6 equal to 30. And the mean is the central value around which we will measure the spread. Next, we will find the deviation of each observation from the mean. That means we subtract the mean, which is 30, from each data point. So this step shows us how far each value is from the center of the data set. So let's write out each deviation. 5 minus 30 is minus 25. 15 minus 30 is minus 15. 25 minus 30 is minus 5. 35 minus 30 is 5. 45 minus 30 is 15. 55 minus 30 is 25. Now square each deviation. Then we obtain minus 25 whole square is 625. Minus 15 whole square is 225. Minus 5 whole square is 25. 5 square is 25. 15 square is 225. And 25 square is 625. Now let's add up all the square deviations. 625 plus 225 plus 25 plus 25 plus 225 plus 625. The total is 1750. This sum is called the sum of squares, and its key step in finding the variance. So for set A, the sum of the squares of the deviations from the mean is 1750. So this number represents the total variability in our data set. Now we are exploring the concept of variance. Okay, so here we are taking example for set B. So the observations are 15, 16, 17, dot dot dot, 45. So there we have 31 numbers. Now we need to calculate the mean. So mean equal to sum of all the numbers from 15 to 45 and then divided by total numbers, that is 31. So here the sum of the numbers 15 plus 16 plus 17 plus dot 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 plus 45, and the total numbers is 31. So 15 plus 16 plus 17 plus dot 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 plus 45 divided by 31, and here sum of 15 to 45 is basically 930, and so mean is equal to 930 divided by 31, and this is equal to 30. Let's find the deviations from the mean for the first few observations. Okay, so a deviation is simply the difference between each number and the mean. So we will look at the first few numbers to see how far they are from 30. So now let's see here the deviations from the mean. 15 minus 30 is minus 15. 16 minus 30 is minus 14. 17 minus 30 is minus 13. 18 minus 30 is minus 12. 19 minus 30 is minus 11. 20 minus 30 is minus 10. Now square each deviation for the first few. Minus 15 whole square is 225. Minus 14 whole square is 196. Minus 13 whole square is 169. Minus 12 whole square is 144. Minus 11 whole square is 121. Minus 10 whole square is 100, and so on. Now add all the squared deviations for all 31 observations, and sum of squares of deviation is basically 2480. Now let's look at the sum of squares of deviations, which is written as sum xi minus x bar whole square. Here xi represents each data value and x bar is the mean of the data set. So if we use this sum as our measure of dispersion, so we might mistakenly think that set A, which has 6 observations, is less spread out than set B, which has 31 observations. But this is not always true, and we will see why. So this confusion happens because set A actually has values that are more spread out from the mean with deviations ranging from -25 to 25. In contrast, set B's deviation only range from -15 to 15. So even though set A's values are more extreme, the sum of the squares might not reflect that, and if we don't account for the number of observations. This is also clear from the following diagrams. So here you can see for the set A, we have this diagram, okay, figure 13.5, and for set B, we have figure 13.6. Okay, so this figure will clear our confusion. Okay, so this shows that sum of squares alone is not a proper measure of this person because it depends on the number of observations. To solve this problem, we divide the sum of squared deviations by the number of observations, which we call n. Here is the formula for variance. Variance equal to 1 divided by n into summation I equal to 1 to n xi minus x bar whole square. For set A, variance is 1750 divided by 6 is equal to 291.67, and for set B, variance is 2480 upon 31 is equal to 80. Okay, here in this formula you should note down n is basically number of observations, xi data point, x bar is the mean of the given data point. Okay, so from these results we can see that set A has a higher variance than set B. This means set A's data is more spread out or has more scatter than set B. So this matches what we would expect if we looked at the range of each set. So by taking the mean of the squares deviations from the mean, we get a much better measure of how spread out the data is. The method corrects the problem we saw earlier with just using the sum of the squares. So this measure we have been talking about is called the variance, and we use the symbol sigma squared, written as sigma square, to represent it. So remember, variance is a key concept in statistics for understanding data dispersion. So we will continue building on this idea in the next part. Now let's look at how actually calculate variance for n observations, which we can call x1, x2 up to xn. The variance is a way to measure how far each value is from the mean or average of the data. Here's the formula written out. Variance sigma square equal to 1 divided by n into sum from I equal to 1 to n of xi minus x bar whole square. Then the square root of the variance is the standard deviation. Okay, the next important concept is the standard deviation, and it is denoted by sigma and give by sigma equal to positive square root of variance. Now we are going to learn how to calculate variance and standard deviation, which are two important measures in statistics. This helps us understand how spread out or clustered our data is. So we will break down the process step by step so you can see exactly how each part works. So let's start by considering that we have n observations, which we will call x1, x2 up to xn. Step 1 is to calculate the mean, so which is the average of all our data points. The mean is the central value that represents our data set. So we will use this mean in the next steps to see how each value differs from it. So the formula for the mean is mean equal to summation xi divided by n. Step 2 is to calculate the squared deviations. This means we look at how far each data point is from the mean and then square that difference. So for each xi, we find xi minus x bar. So if xi is 6 and the mean is 4, the square deviation would be 6 minus 4 whole square, that is 4. So we do this for every data point in our set. Step 3 is to sum up all these square deviations. So we calculate sum of xi minus x bar whole square for all I from 1 to n. Step 4 is to calculate the variance, which we use the symbol sigma squared. For variance tells us the average squared distance from the mean. So to find the variance, we divide the sum of squared deviations by n. Therefore, variance sigma squared equal to sum from I equal to 1 to n of xi minus x bar whole square divided by n. Finally, the standard deviation is just the square root of the variance. So standard deviation sigma equal to square root of summation from I equal to 1 to n xi minus x bar whole square divided by n. Now let's look at an example. So we are given a set of data 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So our goal is to find both the variance and standard deviation for this data. So to solve this, we need to use the formula for variance. The formula is variance sigma squared equal to summation fi times xi minus x bar whole square divided by n, where n is the total number of observations, that is n equal to summation of fi. Okay, and fi is the frequency of each value xi and x bar is the mean. Now let's recall how to find standard deviation. The standard deviation sigma is simply the square root of the variance. Now step 1 is to calculate mean x bar. So x bar is equal to 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20 plus 22 plus 24 divided by 10, which is equal to 150 upon 10 and which equals to 15. Now for step 2 and 3, we need to calculate the sum of squared deviations. This means we subtract the mean from each data value and square the result and then add up all those square differences. The formula is sum from I equal to 1 to n of xi minus x bar whole squared. Now summation I equal to 1 to n xi minus 15 whole squared, this is equal to minus 9 whole square plus minus 7 whole square plus minus 5 whole square plus minus 3 whole square plus minus 1 whole square plus 1 square plus 3 square plus 5 square plus 7 square plus 9 square. Now let's add up all those squared values. We get 81 plus 49 plus 25 plus 9 plus 1 plus 1 plus 9 plus 25 plus 49 plus 81, and the totals is 330. So this is our sum of squared deviations. Now step 4 is to calculate the variance and the standard deviation. Now let's find the variance. So we take our sum of square deviations 330 and divide by the number of data points, which is 10. So variance equals to 330 divided by 10, which is 33. Finally, to find the standard deviation, we take the square root of the variance. So sigma equals square root of 33, which is approximately 5.74. So I hope this is clear to all of you. Now we will see some extra question on this topic. So let's see here. Let's examine a statistics problem where we have two sets of data and need to combine them to find the overall standard deviation. So here this question gives us the mean and standard deviation of some data for the time taken to complete a test are calculated from 25 observations with a mean of 18.2 seconds and a standard deviation of 3.25 seconds. Further, another set of 15 observations x1, x2 up to x15 also in seconds is now available. With the sum of these observations given by summation I equal to 1 to 15, xi is 279, and the sum of the squares of these observations given by summation I equal to 1 to 15, xi square is equal to 5524. Now calculate the standard deviation based on all 40 observations combined. So first of all, try it yourself. So let's solve this question step by step. So see the solution step by step. So we have given that in first set we have 25 observations. So n1 is equal to 25 and mean x1 bar is 18.2 and standard deviation sigma 1 is 3.25. In second set, number of observations n2 is 15, sum of observations is summation I equal to 1 to 15, xi is 279, and sum of squares of observations summation I equal to 1 to 15, xi square is equal to 5524. So summation sum of squares of observations summation I equal to 1 to 15, xi square equal to 5524. So first let's calculate the sum of all observations in the first set. So this is important because we will need to the total sum when we combine both data sets. So we will use the formula sum x1 equal to n1 into mean of x1. So since x1 bar equal to summation xi xn upon n, it implies summation x1 equal to n1 times x1 bar. This is equal to 25 into 18.2 and this is equal to 455. Next, in step 2, we will calculate the sum of squares for the first set using the formula for variance. Sigma 1 square equal to summation xi square upon n1 minus x1 bar whole square. So sigma 1 square, this is equal to summation xi whole square divided by n minus x1 bar whole square. It implies summation xi square equal to n1 times sigma 1 square plus x1 bar square. And we know variance of first set is sigma 1 square and here sigma 1 is 3.25. So variance of first set is 3.25 whole square, that is equal to 10.5625. Since x1 bar equal to 18.2, so it implies x1 bar square equal to 18.2 square equal to 331.24. since summation xi square equal to n1 times sigma 1 square plus x1 bar square. So summation xi square equal to 25 times 10.5625 plus 331.24, and this is equal to 25 times 341.8025, and this is equal to 8545.0625. Now step 3 is to combine the sums and sums of squares from both sets. So we know summation x equal to summation x1 plus summation x2. We have found summation x1 is 455 and summation x2 is 279. Then it implies summation x is 455 plus 279. This is equal to 734. We know that summation x square equal to summation x1 square plus summation x2 square. And we have found summation x1 square is 8545.0625 and summation x2 square equal to 5524. It implies summation x square equal to 8545.0625 plus 5524 equal to 14,069.0625. So step 4 is calculate the combined mean. So we know x bar equal to summation x upon n plus 1, n plus n2. So we know x bar equal to summation x upon n1 plus n2, and we have summation x equal to 734 and n1 plus n2 is 40. So it implies x bar equal to 734 upon 40, and this is equal to 18.35. Step 5 is to calculate the combined variance. So we know sigma squared equal to summation x square upon n1 plus n2 minus x bar square. And we have summation x square equal to 14,069.0625 and n1 plus n2 is 40 and x bar is 18.35. So it implies sigma squared equal to 14,069.0625 divided by 40 minus 18.35 square. This is equal to 351.7265625 minus 336 minus 336.7225 equal to 15.0040625. Now step 6 is to calculate the combined standard deviation. We know sigma equal to square root of sigma square. Here sigma square is 15.0040625. So it implies sigma equal to square root of 15.0040625. It is approximately equal to 3.87. That's all for today's lecture, and thank you for your attention. I hope this lesson was helpful to all of you.